Okay, hey everybody. Okay, this is super exciting. This is a really big room. Hey, I'm Victoria, and today I'm presenting TruCol. It's a decentralized, trustless collaboration protocol for test-driven development. And we aim at increasing developer autonomy and market efficiency by leveraging the power of smart contracts in a bounty-based system. So first of all, a little overview of the presentation. I will tell you why we are here, how it works, the challenges that we face, how we approach them, and the various applications of the protocol and its impact. So first of all, why? Why are we here and why did we develop this? So we started developing the protocol at the East Denver hackathon earlier this year, after we noticed that we did not always have the time or skill for specific coding work ourselves when we were setting up our own company. And we thought setting out bounties would really provide a great solution for this. However, existing systems really require an often costly middleman and a modicum of trust between all parties. So yeah, for whom is the protocol? So as a company, you may be looking for a specific algorithmic optimization, and you want to harness the power that comes out of a global competition. Also, you would maybe not like to give a large cut of the payout to a mediating platform. And as a developer, you may want to be more flexible with which jobs you take on and when. Perhaps you need a bit of extra cash, or you want to learn a specific skill and practice, or perhaps bounty hunt full-time and would like a more secure and higher payout. So the TruCol protocol allows for both employers and developers to become more independent by removing the middleman and thus the need for trust. Thereby, we increase their autonomy while also increasing the market efficiency. You don't have to spend time hiring people for such jobs. There's no cut taken from the bounty. And the smart contract pays out automatically once the job is fulfilled. Setting out a bounty allows for a worldwide competition, which is especially interesting in the space of algorithmic optimization. We believe that all of this stimulates an open and a fair developer market because it enables anyone in the world to participate, as long as they have access to the smart contracts. This also means that a hiring bias is eliminated, and the thresholds to getting work may be reduced. So how does the protocol work? In short, all you need is 2 smart contracts and a source of randomness. You need 1 contract for a test specification and 1 for a solution. The randomness is to ensure that the bounty hunter cannot hard-code the solution. So suppose Alice, the left one, wants some well-defined challenge to be solved. For example, the most efficient employee scheduling of her company. So she writes a set of unit tests that check for any given solution using some randomized inputs. Alice publishes a unit test in a smart contract and sets a bounty for any other contract that solves it. Bob, the bounty hunter, codes up a solution in his own smart contract, which calls her contract in order to receive the bounty. If Alice's requirements are fulfilled, the smart contract will automatically pay out the reward. So just a little recap, for those who don't know, test-driven development is like a software development practice that determines the quality of a solution on whether it passes the unit tests, which are written before the code itself. It increases the efficiency of delivering good code results, and we think that it has some great potential in also yielding better code solutions. So by increasing the skills of test specification, also the solutions will be of higher quality. And especially in bounty hunting collaboration, utilizing good unit test specification removes unnecessary communication and also ensures a satisfying result for both the employer and the developer. The structure of the smart contract really lend themselves well for test-driven development, we think, because the contracts are essentially pieces of code that are executed when the requirements are fulfilled. So I probably already hear you thinking that gas is super expensive, writing all the tests on-chain in a smart contract is super constraining, it's expensive and constraining when it comes to programming language choice. So yeah, that's true. The user can determine their desired level of decentralization and has the freedom to choose whether they want to publish a test specification completely on-chain or make some use of Git, continuous integration, and oracles to verify the completion of the task. Furthermore, we intend to host a thriving ecosystem in which knowledge is shared, here the users can also find the GUI and API if they want to make use of it, because the protocol is free for everybody to use and implement as they please. But in this ecosystem, they can also find, post, and discuss jobs. Okay, so we already faced with quite some challenges. First of all, we would like to prevent the hard coding of tests. So we propose to do this by, for example, using chain links verifiable random function, VRF, to randomize the test inputs. Furthermore, we would also like to prevent the hacking of tests through edge cases. This can be achieved by proper test specification that cover these edge cases. We would also, as I just said before, facilitate more programming languages beyond Solidity to increase user freedom. We think that there are various solutions to this challenge. An option would be, for example, to implement the protocol on various different chains. This maybe enables using Rust. Another option would be to utilize eWASM to facilitate C and C++, and also enabling some transpiling. Or you can use a smart contract to refer to a Git repository that contains the test specifications and solutions. Together with some continuous integration and an oracle that fetches its status, the smart contract can then be informed of whether the solution has passed the test. This allows for coding in all programming languages instead of only Solidity, and in parallel it significantly reduces the gas costs. So this approach may sacrifice some decentralization, but as you may have seen here on the conference, there are some decentralized CIs available on the market, and we think it's up to the user to choose one that is most suitable for their project. So, protocol weaknesses. After we have faced these challenges, we are left with two weaknesses. First of all, it can be difficult to identify the appropriate task to offload. And second, it can be quite hard to secure your test specification to prevent hard coding, or sorry, not hard coding, sorry, I just lost my words. Not hard coding, but hacking, sorry, the test hacking, yeah. Okay, and this is why we propose a consultancy that helps employers get the most out of the protocol. So the protocol is an idea. It's free for everybody to use, but this is how we approach these weaknesses. So our value proposition is to aid the identification of appropriate tasks to offload into the protocol, and also help improve the security of the smart contract test specification. So its applications are varied. So the protocol is aimed primarily at algorithmic optimizations of NP-hard and complete problems. Yet, the beauty of the smart contract requirement is that you can work with any deterministically verifiable key performance indicator. So for example, an example would be airports that set out some bounties for a predictive passenger model that pay out if the amount of departing passengers is predicted with an accuracy of, for example, 90%. So this can be done with our protocol when the data is published on chain. Another example, something for the future, will be applying the protocol for AI engine specification, such that AI engines such as GPT-3 could auto-generate solutions that are compliant with the requirements. The various established markets that typically deal with algorithmic optimizations and may make use of the protocol are algorithmic trading, logistics, for example, for route scheduling, material science, so for example, algorithmic material discovery, pharmaceutics, drug discovery, artificial intelligence classification. Also, we think there are various upcoming markets that may benefit from the protocol. For example, neuromorphic computing, there are emerging new computational complexity frameworks that may benefit from this worldwide competition. Space engineering, very energy constrained, and algorithmic optimizations are always wanted and needed. Another advantage here in space engineering is that test-driven development is already common practice. Quantum computing, many new algorithmic developments coming and currently taking place. Additionally, we are interested in diversifying our activities, as I mentioned before, facilitating some KPI-based predictive models, using on-chain data, and teaching requirement specifications such that AI engines can also solve some generic tasks. So lastly, the impact. We think this is a practical application of blockchain technology that empowers autonomy of employers and developers. It can enhance the algorithmic efficiency of companies in various sectors. The protocol potentially is of use for many growing markets and exports some expertise. In a thriving knowledge ecosystem, we really believe that this enables an open and fair developer market And we think that the protocol does contribute to UN Sustainability Development Goal 8 by promoting inclusive, fair, and accessible work for all. This is roadmap. We are currently developing the protocol ecosystem and are soon launching the TruCol consultancy. And the help is needed. If you want to join, please contact us. So to close off, we think that the presented protocol has the potential to increase market efficiency and is realized by eliminating the trust between employers and bounty hunters, allowing the middle person to be eliminated from the transactional chain. This way, the protocol creates a free and fair developer market that enables a thriving community in which experience and knowledge is shared. So I would be glad to hear your questions and ideas. Please feel free to contact us and contribute. If you want, check out our website and GitHub. Thank you.
Any questions? No?